AI. It's like a toddler on steroids? Let me explain. Meet Jimmy. We want to teach him to recognize a square. Don't worry, we'll teach him more exciting stuff later. Let's start by showing him a lot of squares. The key is, we need to show him different squares. Some tilted or scaled or slightly imperfect, like you. We also need to show him not squares. Preferably, we'd show him enough to give you geometry-induced nightmares, but around 500 of each should do. Okay, now Jimmy can recognize squares. But how does he actually see? Neurons. No, not neurons. Robot neurons. This part's juicy, so strap in. We'll give Jimmy's brain 4 layers. Input, output, and 2 hidden ones. We'll display his square on this 5x5 grid. That gives 25 pixels, so the input layer has 25 neurons, 1 per pixel. Makes sense, right? Each input neuron shows a number between 0 and 1. 0 means black, 1 means white. These input neurons connect to the first hidden layer. This layer looks for tiny features, maybe a corner here, or a straight line there. It does this by looking at the numbers from several input neurons. Then, the second hidden layer combines these, and maybe that makes a square. And that leaves the output layer. It only has 2 neurons, square or not square. Each option gets a score. The bigger one wins, and that's Jimmy's answer. But that's boring. We don't want Jimmy to recognize squares. We want him to do our taxes. So we start by showing him a lot of data, just like with the squares. Then, Jimmy needs to read. To do that, he uses attention, something you don't have. Imagine he sees this sentence on your tax form. We read it one word at a time. Jimmy doesn't. He looks at the whole sentence at once and breaks each word into a string of numbers. More similar words have more similar strings. This is where attention comes in. He looks at one word at a time and decides how relevant every other word is. This allows Jimmy to tie together words like government and us, which aren't normally linked. But hold on, that explains how Jimmy understands, not how he replies. For that, we need more neurons. A lot more neurons. I'll give you numbers in a second. Jimmy forms his response one word at a time. He uses his neurons to guess the next word. Once he guesses a word, he adds it to his context and guesses the next word. But again, it's all just guesses. This is why data is so important. It gives Jimmy more context, making him more accurate. He's kinda like you. Look, if I show you this picture, you only know it's a cat because you've seen a cat before. You have context from data. But if I show you this, you probably look really confused. In the same way, if you had only ever seen dogs and suddenly you saw a horse, you might call it a dog. They both have 4 legs and a tail after all. And in fact, toddlers do it all the time because they just don't have enough context yet. AI is the same, and that's scary or awesome? I can't tell. But as promised, here are the numbers. GPT-3 had 96 layers, each made of between 12,000 and 49,000 neurons to make 175 billion parameters. And we are way past that model now. Some estimates suggest GPT-5 could have up to 52 trillion parameters, or about the same as 6% of your brain. Yeah, I'll just go now. Jimmy said subscribe though.